Hey guys, hello everyone and welcome to the channel. So this is Nuruluda, and while editing this video on variation theorem, I just realized that I have missed the introduction part of it, so that's why I'm recording it like this. So the video is in the usual form which I used to make, that is on pen and paper mode, and I have tried to explain this variation theorem to you guys in this particular video, and the video size is little longer than my usual videos. It's around 35 minutes and plus like 37 or 38-minute video. So, one thing which I wanted to tell you over here is that this particular topic, that is your variation theorem as well as your perturbation theorem, both are important topics from your quantum chemistry. It's no doubt that both are very important topics, but they are not that easy to be understood by each and everyone. Like every student or every person cannot understand these things very easily. Okay, and it also depends upon what books you are following, or in the way you are getting, like the person is teaching you in what way. Okay, so it depends upon that also. So see, my audience include both kind of students, like from bio background as well as from maths background. So what I have done, I have tried to make this topic, I have tried to make this particular topic in such a way that all of the students, either from the bio background or from maths background, both students are able to understand the things, are able to grab the concept that what kind of questions can be asked, what kind of things are related to your variation theorem. Okay, so this is a 35 minutes video, so try to watch this video carefully. I have taken around 4 to 5 types of questions, and these are the only kind of questions which can be asked in CSIR net. Like these have been asked till now. Okay, like these kind of questions are only asked, and some of them are repeated also. The same kind of questions are repeated also. So I just hope that question in the upcoming exams also will be asked from here only, and with those things your concept of your variation theorem will also be covered. Okay, and at the end of this video I have given a question to practice for you guys. I have given an unsolved question for you guys to practice. Try to do that question very carefully, try to solve that question and give me answer in the comment section. Okay, and also tell me in the comment section that how, like, if you like this. Before starting the explanation part, I'll just request you guys that if you are new to this channel, please subscribe to this channel, and like if you like this video, give it a like, right? So let's start and let's try to understand variation theorem. Now, to save some of your time, I have already written few things over here. So this variation theorem, just like your perturbation theorem, this is also approximate method. Now what does this approximate method means? That means this is not exact, this will not give you exact value, it will just give you an approximate value of energy. Okay, so see what happens actually, that whenever we are talking about quantum chemistry or quantum physics, so over there, if the system is very simple, just for a single particle or a single electron, in that case, like solving a Schrodinger equation or solving any of the equation for a given wave function is easy. But when you have a multi-electron system, if you have more than one electron or more than one particle, in that case it becomes a little difficult to solve the system. Like in that case you will not get that much exact energy. Okay, so that is what one of the complication we have with the quantum system. So that's why whatever you have studied till now in your bachelor's or in your master's based upon your quantum chemistry, that is just for a single particle, just like you have studied that particle in a box. Okay, so there you have studied a single particle inside a box, but it is not like that, right? You might have more than one particle in the box. So for solving an equation for more than one particle in a box, you need certain approximate method, certain method which can give you an approximate value of energy, certain or in the perturbation theorem we try to perturb the energy, we try to correct out the energy whatever we are getting. So perturbation theorem I'll make later, but right now we are just talking about variation theorem. So over here you will get an approximate energy, or it is a approximate method of calculation of energy. Now this is used for the system like little complex system like multi-electron systems. Okay, and this is used to find out exact energy, or like you cannot get exact energy in this case in the form of variation theorem by using variation theorem actually. So you will get an energy which will be very near to your exact energy. So you will be getting an energy which is very much near to the exact energy. That means like an approximate value but a very close value to the exact energy. Now for variation theorem, generally we take a trial wave function over here. Okay, so a trial wave function is being taken, and what does this trial wave function do actually? That it's as the name suggests, it's a trial wave function, it's not your original wave function. And what are the properties of this trial wave function is that it's an approximate wave function which is taken very near to the exact energy, which will give you, like the trial wave function will give you a value of energy which will be very close to the exact energy value. So exact wave function will give you exact energy, but
a trial wave function will give you a very it will give you approximate energy which will be very near to your exact energy. Now the average value of your this trial wave function, the energy which you will get from the the energy which you will get from your trial wave function, the average value of that energy will give you exact energy term or nearest to that, or the near value to that. Okay, so always remember that whatever energy you will get from the trial wave function will be always greater than or equal to your exact wave function, exact energy. So this is what you want to calculate, but for a multi-electron system it's difficult to be calculated. That's why we take a trial wave function, and with the help of that we try to make our energy term very much near to this exact energy term. Okay, so this is the thing. All right, so now before explaining your trial wave function and trial energy and all those things, I'll just tell you that how you can find out your average energy value for a given wave function. Okay, so let's take this question. It says that the energy for the given wave function, this is the wave function given to you. So psi is equals to x, L minus 2, L by 2 minus x into L by L minus x. So this is your wave functions given to you for a one dimension box. So this is a wave function which is given to you for one dimension box, and they want you to find out your average energy. Okay, so you want to find out average energy. So how to do that? See, first of all you have to find out the number of nodes over here. So how to find out number of nodes? You just have to put your wave function is equals to 0. So x L by 2 minus x into L minus x is equals to 0. Just put like that. Now what you are going to get? You are going to get 3 value of x. Why? Because you have 3 x terms over here. So that's why you will be getting 3 values of x. The first one will be x is equals to 0. If you just take this term and equate it with equal to 0. So this is the first value. The next one will be with the help of this bracket. So it's like L by 2 minus x is equals to 0. And the third term, like what I have done, I have taken this bracket term and I have equated with 0. Now the third one is L minus x and I will equate it with 0. Okay, so this is x is equals to 0 that I already got. So over here you will be getting x is equals to L by 2, and over here you will be getting x is equals to L. Now this particular one and this particular one, these are boundary condition. Why? Because for one dimension box it's given that you are taking from 0 to L. Okay, so you are taking from 0 to L. So basically your particle is in box from x is equals to 0 so to x is equals to L. So both these things like x is equals to 0 and x is equals to L, both are boundary condition. Okay, so this is also boundary condition and this is also boundary condition. Okay, so this is also boundary condition. But this term over here which you are getting over here in this place, this is not a boundary condition, right? So it's like x is equals to L by 2. So when you what does that mean? That when you put x is equals to L by 2 at this particular value, you will be getting 0 value for the wave function. So the wave function will become 0. So that means probability of finding electron over here is 0. That means what it is? It's a node. Okay, so it's a node. Now how much node you got? So you got just one node. At what value? At L by 2. L by 2 is the value, and how much node you got? You got one node over here. Okay, now yeah, so there is the formula to find out. Okay, so number of nodes is equals to n minus 1. Okay, so n is your like the number which you put over there. Okay, so yeah, so number of nodes over here is 1 and is equals to n minus 1. So what will be the value of n over here? So n is the principal quantum number, right? So it will go to the other side. It will be 1 plus 1 will give you 2. So n is equals to 2. So what is the value of energy? So your energy is equals to, for one dimension box you have this formula, right? N square h square upon okay, so n square h square upon 8 ml square. So this is the formula. If you put n is equals to 2 over here, so energy you are going to get as 2 square h square by 8 ml square. This will give you 4 h square by 8 ml square, or you are going to get h square by 2 ml square. So this will be your average energy value. Okay, so like that you can calculate your average energy for a given wave function. Now we will use whatever we have taught, like whatever we have studied for your trial wave function, and we'll try to see that what kind of questions can be asked from your variation theorem. Okay, so let's see and let's solve them. All right, so let's take this particular question from CSIR December 2014 exam. Okay, and the question says that for some one electron system with L is equals to 0 and M is equals to 0, the functions, this is one of the function, wave function, and this is one of the wave function, refer respectively to the ground state and the excited state. Okay, so this is for the ground state, this particular one is for ground state, and this particular one is for excited state even energy levels, right? So if variation function, this is the variation function, this means this is the trial wave function which you are using, yields the average value of E bar. So E bar is the average value which you are getting from the trial wave function. Okay, now it will satisfy which of these equations. So first of all, I'll just write down few things. So we have like the base wave function or the ground state wave function is n naught e to the power minus sigma. This is your ground state. Then for excited state you have like psi1 is equals to n1 and 2 minus sigma and e to the power minus sigma by 2. So this is what you are going to get now. So yeah, it's very simple. Okay, I will just tell you how you have to solve, and then I will tell you the basic way of how to find out the answer. Okay, very easy way. First of all, just try to find out like the value number of nodes in all of these. So how to do that? Just put equal to 0, right? So just take it equal to 0. Okay, I'm just solving for the ground state first. Just look up onto this area first. So if you put like that, so it will come out to be an e to the power sigma is equals to 0. Now this function is actually not a function of x, not a function of n, but a function of sigma. Okay, so you have to find out value of sigma now. So if e to the power minus sigma is equals to 0, then sigma will be equal to infinite. Okay, so always remember this. If e to the power sigma is equals to 0, and then it will be equal to then sigma will be equal to 0. But if e to the power minus sigma is equals to 0, in that case sigma will be equal to, so that means e to the power sigma will be 0, then okay, so then sigma will also be equal to 0. Okay, but if your so if it is like that, okay, so I think it should be if e to the power sigma is equals to 1. Okay, so if it is like that, then sigma will be equal to 0 because e to the power 0 will give you 1. Okay, so over here you have e to the power minus sigma, right, and that is equals to 0. So your sigma will come out to be infinite. Okay, so yeah, so this is the thing. So this is a boundary condition. You know this thing, right? So this is boundary condition. Why? Because sigma is equals to infinite is like the highest boundary you can take is infinite. So that's why it will become a boundary condition. Now for the second wave function, just take it equal to 0 now. So yeah, now what will come out to be, it will like 2 minus sigma is equals to 0, and also like and e to the power minus sigma by 2 is equals to 0. So what does this mean? That sigma is equals to 2 from here, and you will be having like sigma minus sigma by 2 is equals to infinite, or sigma is equals to infinite. Okay, so this is what we are going to get. Now this is again a boundary condition over here. So but this is a node, right? This is a node. So now for your excited state, how many node you got? You got one node at sigma is equals to 0. So okay, so if you now, and how many node you got for this? So for ground state you are getting 0 node. So now you can find out, with the help of that you can find out the energy term, right? So for ground state energy, it's like, okay, so just find out for the node, we have formula like n minus 1 is equals to number of node. So since we have 0 node over here, so I'll just write 0 over here, so n is equals to 1 over here, right? And for here we will be having n minus 1 is equals to 1 because we just got one node. So now what will be the value of n will be equal to 2, right? So now just find out the value of energies. For ground state you will be having like n square h square upon 8 ml square. Now because this is for, okay, so this is not for a particle in one dimension box. So okay, so let's leave it like that only. So it's not for a particle, it's not a particle in one dimension box, so you cannot use this equation actually like for the energy term. But you know that in the one in which you have n higher value of n, that will have a higher energy value, right? So now you can say that E1, which was for this excited state, this will be greater than E0, okay, because E0 is your ground state. So that's how you will be getting this, that E1 is equals to E0, sorry, E1 is greater than E0. Now these both were exact energy terms which we have calculated. So these are your exact energy values, average energies, exact average energies. Now there is one more which is given to you as a trial wave function, that is n2. Now you have psi trial as n2, then 3 minus sigma and e to the power minus sigma. If you want, you can calculate also. If you don't want to calculate, just write down that you are getting an average energy over here, that will be E bar. Okay, so E bar will be the average energy from this trial wave function. Now I have already told you that E trial is always greater or equal to E exact, है ना? So now what you have to do, just put this thing that E trial over here is E bar, and that will be always greater than or equal to these two, because both of them are exact value. So how they two are related? They are related like this. So E1 is greater than E0. So this is what the relation which you are getting, like E0 is the smallest one and E bar is the highest one. Let's see in the option where you are getting like that. So E0 is the smallest one over here, but E bar is not highest one over here. So this is not our correct option. Okay, so this is not our correct option. Okay, so is there any else option over here? It's like 0. So 0 we don't have any value 0 over here. So the only option which can satisfy your term is this, that is option number 3. How it is? Because it is saying that E bar, that means your E bar, okay, E bar is greater than E1. So this is just satisfying up to here. So they are just asking the relation between the only two. Okay, they have not given the ground state one, so you don't have to consider but this is true, na? Option 3 is true. So you can say that option 3 will be your correct option. So in this question, although they have given data for ground state, excited state and trial, all three, but they are just asking relation between the two. Okay, and they have just tried to confuse you guys, and it was not that difficult. Okay, so it was very simple. Now the other way to do this question, the other way, like the easier way, okay, just by looking to the question you can find out, and it was asked for 4 marks. So just by looking to the question you could have done this question. And how to do that is just look upon to the where you have, like, you know that E exact is always less than your E trial. Okay, so E trial is your E bar, hai na? So just look in the option where E bar is highest one, where E bar is given as the highest one. So your option number 2 also cannot be correct because E bar is given less than E0, which cannot be possible, and option 4 is also not possible. The only one in which E bar is given highest one is your second, and first one can also be correct because like your average from your like average energy from the like the trial energy will be greater than 0, but it will be 0 if your E1 and E0 both will come out to be 0. But over here they are not 0 actually, they will have some value because the n values are some that is not 0, so they will have certain value, right? So that is why your option number 2 is the correct option. Okay, so you can easily cancel out 2 options by just looking into them. So that's how you have to do question from here. Now let's take few more types of question and try to see that how to do them. Okay, so this is the next kind of question which can be asked from your variation theorem, and this is the next part of it. It is called your linear variation theorem. Okay, so this is also very simple, and what does it says that if you have, let's say you have a wave function psi and it's a linear combination of 2 more wave functions, those are phi1 and phi2. Okay, so what it says that if your wave function has more linear parameters, then for that your E trial will have nearest value to the E exact value. So what does that mean? That let's say we have two wave function. Let's say we have psi1 is equals to c1 phi1 plus c2 phi2 plus c3 phi3. Okay, and this one let's say it's a psi naught. Okay, so the energy which we will get, so both are trial wave function. Let's consider that both of them are trial wave function. That means psi naught and psi1 both are trial wave functions. So this one will give you energy of E0 and this one will give you energy of E1. Okay, so these two are trial wave functions, so that's why I'm just writing bar over there, so that it signifies that these energies are resembling the energy of a trial wave function. Okay, now if I ask that which one of these two, like E1 or E0, which one of that will be more closer to the E exact, so what will be the answer? The answer will be E1 bar. Why? Because it has more number of linear parameters. That's it. Okay, sorry, it should be phi. Okay, so it should be c2 phi2 and c3 phi3. Okay, so what does that mean? That the wave function which has more number of linear parameters added or linear parameters attached to each other as a linear combination of wave functions, so that wave function, that particular wave function, that particular trial wave function will give an energy term, will give a trial energy that will be more nearest to E exact. Okay, so now how a question will be asked based upon this. So see, this is a question which has been asked in your CSIR net exam. So it says that for a particle in one dimension box, okay, there is a particle in one dimension box, it has a ground state energy E0. So it has a ground state energy of E0, and the expectation value with like psi trial, you have a trial wave function given as like x minus a, gives you energy E1. Okay, so this is the expectation value or the average energy value. Okay, the next is the energy using linear combination of these eigenfunctions, means this and this. If you do linear combination of these two, then you obtain expectation value or a or the average energy as E2. Now you have to find out relation between E1, E2 and E0. Okay, you have to find out relation between all three. So how you have to do? First of all, let's say for psi trial, okay, I'm just writing it as psi trial. You have x minus a, so it's first kind of your trial wave function, and it is giving energy E1. Okay, the next one will have psi trial. This is also psi trial, but it's like psi trial 1 and it is psi trial 2. Okay, so the second trial wave function is a linear combination of these two terms. Okay, so I'll just add both of them, so it's like x minus a plus x square x minus a whole square. So it's a linear combination of these eigenfunction, and this will give you energy of E2. Okay, so here you are getting E2, here you are getting E1. Now E0 is what? It's exact energy. Okay, it's exact energy or exact average energy. Okay, so this we all know, and we also know by the variation theorem that E trial is always greater than or equal to your E exact. So it's E exact. Now you have two trial wave function. You have two trial wave functions, E1 and E2. So basically both of them, E1 and E2, both of them will be greater than E exact. So we have E exact as E0. So both of them will be greater than or equal to that. But which one will be closer to it? So the one which has more number of linear parameters, it has two linear parameters, it has just one linear parameter. So the one which has more number of linear parameter will be closer to your exact. Okay, so E2 will be closer to your E0, and your E1 will be more greater than that. Means it will have value greater than E0, but it will be farther from that. So the value you will get for E1 will be much away or much farther as compared to the value which you will get for E2. Okay, so this is how you have to utilize your like understanding of your linear variation theorem, right? So this was your second kind of like problem which can be asked based upon your linear variation theorem. Now I'll just take a last kind of question which was asked in CSIR December 2017, sorry, CSIR June 2017. Okay, and I'll try to explain you that how to do that question. Right, so let's take this particular question which was asked in CSIR June 2017 exam, and it was asked for 4 marks. And this is this is a different kind of question which you have just solved. Okay, so this is not that kind of question, it is quite a different kind of question, and these kind of questions are generally asked. Okay, so I'll give you one more question after this question. Okay, so I'll just give you that question to solve. First I'll solve this question. Okay, so it says that given a trial wave function, so this is a trial wave function, and as soon as you get this trial wave function, you have to see, like it should strike to your mind that this question is from your variation theorem. Okay, so now it's given that the trial wave function is this, that is phi is equals to C1 psi is equals to C1 phi 1 plus C2 phi 2 is a Hamiltonian matrix. Okay, sorry, given that a trial wave function is this and a Hamiltonian matrix element, so these are the matrix element which are given to you actually. So the variationally determined ground state energy is, so they want you to find out variationally determined ground state energy. So how to solve this question? So let's try to do it. So first of all, your trial wave function psi or psi trial is what? It's like C1 phi 1 plus C2 phi 2. So this is what our trial wave function is. Now matrix elements, and that too Hamiltonian. Okay, so these are Hamiltonian matrix element. So these are given like this. So you have like psi 1 star H psi 1, and that is given to you like, and dv is also there, that is equals to 0. Then you have sorry, it's not psi, it's phi. Okay, so phi 1 star H phi 2 dv, and that will be equal to 2.5. And then you have like phi 2 star H phi 2 dv is equals to 12.0. So these are the values given to you. So now I'll just write down them in a simplest form. Okay, so what I can write this term as this, that is I can write it like this. So H11 means this H is actually being calculated between your phi 1 and phi 1, so that's why it is H11. So it's 0 given to you. Okay, now the next one is your H12, right, and that's value is 2.5, and the next one is your H22, and its value is given to be 12.0. Now since it follows like the Hamiltonian is your like it is a orthonormal set or a orthonormal like orthonormal, it follows orthonormality basically. So that's why your H12 will be equal to your H21. So H21 will be also equal to the same value, that is 2.5. So that means if you write it like this, that is integration of like phi 2 star H phi 1 dv, that will be also equal to 2.5. So that's what I mean. Okay, so now you have got four values, like all the four values over here. Now what we are going to do is we are going to put it in the secular determinant. Okay, so I'll just write down the secular determinant first of all. So the secular determinant for this thing will be like this. So it will be like H11 minus ES11. Okay, where E is the energy which we have to calculate. Then we have H12 minus ES12. What you have to do, you have to write 1 1 1 2 if you are third term, so it will be like H13 ES13. Okay, so like that it will be, but we just have like 1 1 1 2 2 1 and 2 2, so we have a 2 by 2 matrix. So I'm just going to write the four terms only. So H21, okay, minus ES21, and then we have H22 minus ES22. So this is the determinant which we have got. So to calculate your energy, basically I'm not going into the theoretical values, like the theoretical explanation of all these things, but in order to calculate your energy from the secular determinant, what you have to do, you have to put all these determinant value is equals to 0. Now we know the value of H11, H12, H21 and H22, but we don't know value of S11, S12, S21 and S22. So what does that mean? How to put that? So there is a way of finding it out. Actually, if S is like Ij, okay, so it will be equal to 1 if I is equals to j. That means if both of these things are equal, and it will be equal to 0 if I is not equal to j. Means if you have different values, that means for, okay, so that means what, that your S11 will be equal to 1 and then S12 will be equal to 0 because your I and j are different over here, right? And similarly your S21 will be equal to 0 but S22 will be equal to 1. Now just put all the things which you have got over here. So H11 if you put it as 0, so it's like E, and S11 is 1, so it will just become like E into 1, so that will be just like E. Okay, it's a determinant over here. Now you will be having 2.5 minus E into 0. Okay, the next one is like 2.5 minus E into 0, and the last one is like 12 minus E into 1. Okay, so just write it like this, and that is equals to 0. So how it will be reduced actually? So you will be getting like this. So you will be getting minus E, you will be getting 2.5 over here because E into 0 is 0, then 2.5 over here as well, and then 12 minus E. So now what you have to do, you have to solve this. So to solve a determinant is equals to 0. Okay, so how to solve this determinant? First of all, multiply these two terms. So just multiply these two terms, so it's like minus E into 12 minus E. Okay, and then you have to put a negative sign and then multiply these two, so it's like 2.5 into 2.5 and equal to 0. So just multiply them and solve. So once you open the bracket, you'll be getting like minus 12e plus e square minus 6.25 is equals to 0. And if you like arrange it out, so it will be like e square minus 12e minus 6.25, and that will be equal to 0. So it's a quadratic equation. Now you can solve this quadratic equation using SD formula or using factorization also. So I'm not going to solve it. Okay, I'm just telling you that how to do. So you can use this formula actually. So your E is equals to minus B. Okay, so the SD formula which you must have studied in your class 10th. So it's like minus B, that means minus 12. Okay, minus B plus minus under root B square means your minus 12 square minus 4AC. So at the place of A you have 1, at the place of B you have 12, and at the place of C you have minus 6.25. So 4 into A, that is 1, and C is minus 6.25, and divided by 2A, so it's 2 into 1. So when you will solve it, you will get two values of energy, that will be like minus 0.5, and you will also get a value of 12.5. So what they are asking is the ground state energy. So ground state energy will have a lower value, so that's why this value, that is E is equals to minus 0.5, will be considered. So that means if this is the question, so your correct option will be your option number 2. Okay, so like this you have to do this question. I'll just give you one more question, and I just expect your answer You have to solve that question and tell me what is the answer you are getting in the comment sections. Okay, so before giving you a question for practice, I'll just explain you a last kind of problem which can be asked, like a last kind of different, like a different kind of problem which can be asked based upon variation theorem, where you don't have to use actually your variation theorem. Okay, without using your variation theorem also you can do these kind of question, where it is given like this, that a trial wave function of simple harmonic oscillator is this, that is e to the power minus cx square. Now energy value is, now this is the energy value, so this energy value is given to you, this, that is h cross c upon 2m plus m omega square by 8c. So over here you can see that the energy is actually in the term of c. Okay, it's not in the term of x, it's in the terms of c. Now you have to find out the minimum energy by the variation method. So in order to do this question, if you are a mathematics student, you know that what maxima and minima is. Okay, it's very important concept which you must have studied in your class 11th or 12th. Okay, so over there we have studied maxima and minima concept, what we do over there. So the similar concept we will apply over here. Okay, so the energy term is given to you, that is E is equals to h cross c by 2m and plus m omega square divided by 8c. So this is what your energy is given to you. So the first step of doing your maxima minima kind of question is that you have to divide this energy with, like, you have to differentiate this energy term with respect to the function of which it is. So it's a function of c, so you have to differentiate with respect to c. So if you differentiate with respect to c, so it will be like dE by dc, and that will be equal to, like, what it will be, like d by dc of this two terms, right? So it will be h cross c by 2m plus m omega square by 8c. So this will be like that. Okay, so now what you have to do, just differentiate both these terms one by one. It will be like d by dc of your h cross c by 2m and plus d by dc of your m omega square by 8c. So this is what you are going to get over here. Okay, start okay, so now once you start differentiating these terms, so it's like h cross and 2m are constant, so h cross by 2m you will take like this, and you have to differentiate actually this c. Okay, so you have to just differentiate this c over here, and over here your m omega square by 8 is constant, so that will come outside, and you have to differentiate this 1 by c. So for those who don't know, differentiation of x with respect to x gives you 1, whereas differentiation of x with respect to 1 by x gives you so that will give you like minus 1 by x square. So this is what you will get. So the same way, if you are differentiating c with respect to c, so you will get 1 over here, so you will just get h cross by 2m over here, whereas in the second term you are differentiating c with respect to c, so that's why you are going to get what, you are going to get 1 minus 1 by c square. Okay, so you will be getting minus m omega square by 8c square. So that's what you are going to get. So now what you have to do, just look, okay, so this for maximum minima kind of thing, you have to take this dE by dC should be equal to 0. So that means this particular term is equals to 0. So you can take it like this, so you can just write it over here, that okay, I'm just writing over here, so h cross by 2m plus minus, okay, so plus minus become minus m omega square by 8c square, that is equals to 0. So that means your h cross square by 2m, that will be equals to m omega square by 8c square. Okay, so it's m omega square. Okay, so now you have to calculate the value of c. So just rearrange them and you will find out that c square is equals to m square omega square by 4h cross, right? Because this 2 will cancel out this 8, this c square will come that side, m will multiply with m to give you m square, omega square is already there, and h square will come downside to become okay, so it's h cross square, right? So now what is the value of c now? So the value of c will be equals to what? It will be equal to m omega by 2 h cross. Okay, so you will be getting two values, plus and minus, you have to take the positive value. So this is the value of c you are getting. Now you have to find out minimum value of energy, right? So that's what they were asking. So what you have to do, you have to put the value of c in this energy value, whatever the energy value it was given to you. So I'll just put it over here. So we were having energy E is equals to what? E is equals to, it was given like E is equals to h cross square, h cross square c and divided by 2m. So this was, and plus m omega square by 8c. So this was the energy term, and we have just calculated like c is equals to m omega by 2 h cross. So I'll just put the value over there. So your energy will come out to be h cross square by 2m into m omega by 2h cross. So this is what I have just put value of c over here, plus your m omega square by 8 into, when I put the value of 1 by c, so 1 by c will be reciprocal of this. So what it will be? It will be like 2h cross by m omega. Okay, now just multiply, calculate, solve, whatever it is cancelling out. So this square and this h cross will be cancelled out, and this m and this m will be cancelled out. So your e you are going to get as h cross, one h cross is left out along with omega, and in the denominator will be getting 4, plus over here your m and m will be cancelled out, and 1 omega and 1 omega will cancel out. This 2 will cancel out it to the 4 time, so you are left out with 1 omega and 1 h cross. So it will be like omega or h cross omega by 4. So what is the overall energy, or what is the energy term which you are going to get? So if you will add both of them, it will be 2 h cross omega by 4, and that will give you h cross omega by 2. So once you check in the options, so h cross omega by 2 is the value which you are getting. So h cross omega by 2 is your correct value for the energy term. Okay, so this is how you can do this kind of question where you have to find out minimum energy and using maxima and minima value. Okay, not using your variation theorem exactly. Okay, so that's all from my side. Whatever kind of questions I wanted to tell you, whatever things which I found that these will be helpful for you from the variation theorem point of view. Now I am going to give you a question for your practice. Okay, so this is the question which I am giving you guys to solve, and I just hope that you will be able to solve it out, and I just hope that whatever I have taught was helpful for you. You guys understood it well. So try to do this question. This question says that the trial wave function psi is a linear combination of c1 phi 1 and c2 phi 2. The value of Hamiltonian is given to you in this form, in Ket and Bra form. So these are given to you in this form. So you have to find out minimum energy. So I'll just give you a hint. Okay, so the hint is that it will be solved using your secular determinant. Okay, so you have to use secular determinant. Okay, the way I have just did one question, it's similar to that. Okay, and the other hint I want to give you is that this thing, that is your phi. Okay, so phi n h phi m can be written like this. So this is equal to, you can write this thing in this form also, that is h n m. Okay, so you can write it like that. I hope you guys understood. So n m. Okay, so like that it will be h11, it will be h12, it will be h22. Just use secular determinant and try to find out what is the value of energy. Okay, so just try to do this question and tell me what answer you guys are getting in the comment section below. So that's all for this video, guys. I hope you guys like this video. If you like this video, and if you are new to this channel, please subscribe to this channel, and if you like this video, share with your friends and give it a like, and don't forget to subscribe the channel if you are new to this. Okay, so I'll just bring up with more videos with more helpful stuff for your CSIR net as well as GATE preparation. I hope you guys like this video. Okay, so that's all for this video, guys. Thank you so much for watching. Have a great day. Bye bye.